Assalamu alaikum wa rahmatullah, and good day to all of our beloved viewers of the Voice of the Cape's YouTube and Facebook page. My name is Amir Adams, and of course, we are continuing with the Voice of the Cape's online matric revision program for this year 2024. And these sessions are proudly sponsored by the Two Oceans Graduate Institute, an accredited online platform where you can become a primary or high school teacher by studying in the privacy of your home. For more details regarding this, you may visit www.togl@.ac.za, or you may call the number 021 829 7015 for more information. And that is, of course, pertaining to our official sponsor for this year's Voice of the Cape's online matric revision program, which is, of course, being sponsored by the Two Oceans Graduate Institute. Without further ado, it gives me great honor and privilege to be introducing our facilitator for today's paper, or for today's session rather, and that is none other than Muallima Fatima Karbary. She will be giving discourse and guidelines regarding preparation for physics. And for today's particular endeavor, it's not only just physics, but more so pertaining to Newton's law. So as a reminder to all of the parents out there, all the youth out there, the students, those who are in matric, and specifically those who are doing physics, please forward and share this link with all of the matriculants out there who are preparing for the upcoming physics paper, of course for the trial examination period, and of course later in the year for the NSC exams. And we make dua and pray that God Almighty Allah grants all of our matriculants all the success as they prepare for the upcoming examinations. Without further ado, as I indicated, it gives us great honor and privilege to be handing over and calling upon our esteemed facilitator for today, none other than Muallima Fatima Karbary, will facilitate today's session and give us guidelines and advice and discourse as to how we can prepare for physics, inshallah ta'ala. Without further ado, we hand over to Muallima Fatima Karbary.
Assalamu alaikum wa rahmatullahi wa barakatuh. I pray for him as well, alhamdulillah, and that the study preps are also going well. Today, inshallah, we will be focusing on Newton's second law, which always seems to be question number 2 in your exam paper. We're specifically going to be working through the November 2023 NCS National Senior Certificate exam. So this is the latest one, the one that the matriculants wrote last year. So it's very nice, alhamdulillah, to do preparation via looking through previous examination papers. This is the best way one could possibly study. So we look at question 2, right? This will be question 2 of the November 2023. Okay, if you want to just refer to it, question 2 of the November 2023 physics paper 1. So let's just look at, I'll just place the question in front of us, if you can see it here on the screen. So let's read through the information. It says, 2 blocks A of mass 4 kilograms and B of mass 9 kilograms are connected by a light inextensible string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. A constant force F acting parallel to the plane is applied to block B as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. And so we have a diagram here which they've illustrated for us. You have block A over there, 4 kg. There's a string between the blocks, block B, 9 kg. You can see it's being pulled parallel up the slope by a force F. And we see the slope, the incline of the slope, it's an incline of 35 degrees Celsius. Sorry, 35 degrees. So the first question that I ask over here, 2.1, it's often your theory question. For 2 marks, it says state Newton's second law of motion in words. This is oftentimes in the previous exams, it's always there. So make sure to memorize this. I will just give a short statement of what they're expecting you to say. Newton's second law is when a net force acts on an object, the object will accelerate in the direction of the force. And the acceleration is directly proportional to the net force, and it's inversely proportional to the mass of the object. So this definition you'll find in your textbooks. Make sure to memorize it. It's 2 marks. That might not be a lot, but every mark counts. You know, that mark can be the difference between a B and an A, or it can be the difference between a C and a B. So make sure to memorize it. It will most likely come in your upcoming exams. Then they give further information, and they say the kinetic frictional forces acting on block A and B of 5.88 newtons and 13.23 newtons respectively. Respectively meaning that the 5.88 newtons is being applied on block A, and the 13.23 newtons of friction is being experienced by block B. And then question 2.2, they say for 4 marks, draw a labeled free body diagram showing all the forces acting on block A. Okay, so they want us to draw a labeled free body diagram showing all the forces acting on block A. And besides the 4 mark, the mark allocation is also a very important indicator in terms of how much forces are they expecting us to draw. Okay, a lot of the time if it's a 2 mark question, that's a hint that there's 2 forces acting on the block. If it's 3 marks, it's 3 forces acting on the block. Because it's 4 marks, in all likelihood, this means that when we draw our free body diagram, we're going to encounter 4 forces. I will just switch now to the whiteboard so you can see how we will answer this question. I've drawn the diagram on the whiteboard over here, so we have the same scenario as what is in the question paper. And now we proceed to draw the free body diagram. What is a free body diagram again? It's basically, it's a diagram of where you'll draw a dot, okay? First you begin with the dot. The dot indicates the block, okay? So you don't draw the actual block itself. We just draw a dot. The dot is a representation of block A. And now we're going to draw all of the forces acting on that dot, meaning acting on the block. And the first one, which is always in existence, is always the gravitational force, okay, which is we illustrate it as Fg. Okay, you don't necessarily have to do it as Fg. You can sometimes, some people write it as W. W means weight, so that is also acceptable. But I will just go with Fg, which is the gravitational force, and this is the attractive gravitational force of the Earth acting on the block, what we otherwise in everyday terminology know to be gravity. They also wanted labeled, so it would be good maybe either as part of it or maybe on the side just to expand. And Fg is the gravitational force, okay? Referring to the gravitational force. Gravitational force. Okay, so that's the one force that this block A will experience, the gravitational force of the Earth on it. What other forces will block A experience? Another force block A is going to experience is what we call the normal force. Okay, and what is the normal force? Normal force is the force of the surface on the block. Okay, all surfaces in existence, all surfaces, they exert a force on the objects that are lying on them. So this block is experiencing a force by the surface of this inclined plane. Okay, the inclined plane is exerting a force in what direction? This force that the surface exerts, it's always at 90-degree angle to the surface. Okay, so it's always at a 90-degree over there. So 90 degrees to that block will be in this direction. Okay. So it's always at a 90-degree angle to the surface, and therefore we'll have a right angle triangle over there, so exactly upwards in this direction. What we will say this will be northwest. Okay, so that's the other force in reference to the normal force of the surface. Okay, what is applying the normal force? The surface is applying the normal force on the block, on block A. Okay, so now we know it's a 4-mark question, which means there are 2 other forces we need to add. Thus far, we have 2. We have Fg, gravitational force. We have normal force that is acting perpendicularly on the box. The other force will be tension. Okay, the tension of the string. Right, you see there's a string joining block A and block B. Okay, let's just write this string. So all strings, right, they always contain a tension force within them. What direction is block A experiencing a tension? Because the string is to the right of block A, and it's going in this direction in relation to block A is experiencing a tension upwards. Okay, just going to block B. Block B is also attached by a string, but what direction is block B experiencing a force, experiencing a tension force? So block B is actually experiencing a tension force downwards. Okay, so very important to understand the difference. Even though both of them are experiencing the same tension force, okay, the value of the force is the same, the numerical value. However, it's in different directions. Block A is experiencing a tension force upwards, okay, because the string is to the right of block A. However, block B is experiencing a tension force downwards. Okay, why? Because the string is behind block A. It's going in that direction. So we will therefore have T. But remember, they asked us from the perspective of block A. I just want to illustrate that for block A and block B, the directions of tension are different. However, the question specifically wants us to draw the label-free body diagram showing all the forces acting on block A. So from block A's perspective, it's experiencing tension upwards, okay? So we'll have a tension force. So we'll draw, and all these arrows, what do these arrows represent? The arrows represent the forces, okay? That is what the arrows represent. And so you can put T, okay? And T stands for, it stands for tension. So that is the tension force that block A is experiencing. What is causing the tension? It's the string, okay? The tension within the string is causing block A to experience a force in this direction, the northeasterly direction. Okay, we know we have 3 forces. There's one more that we should have because it's a 4-mark question. So therefore, each force will give you 1 mark. The last one that we'll experience is, remember that if you look carefully at the information, they've told us that force. In the information, they say to us that the kinetic frictional forces acting on blocks A and B are 5.88 newtons and 13.23 newtons respectively. So then they tell us the other force, okay, which is kinetic frictional force. So this block is experiencing a kinetic frictional force. Kinetic just meaning that it's in, because this block is in motion. Anytime a block is in motion, it will experience a kinetic frictional force. And what direction will the kinetic frictional force be? It will be downwards. Okay, it will be in a downward direction. We usually label it Fk. Fk means the kinetic frictional force. Why is it downwards? Because the block is moving upwards. Okay, if you look at the information, they tell us that they say a constant force F acting parallel to the plane is applied to block B, as shown in the diagrams below. The blocks now accelerate up the plane at 2 meters per second squared. So because the blocks are accelerating upwards, it will experience a frictional force downwards. Okay, friction always opposes motion. What this means is, just say you have an object that is moving to the right. If the object is moving to the right, in what direction will it experience friction? It will experience friction to the left. Okay, it's always in the opposite direction of motion. So if the block is moving to the right, it will experience kinetic friction to the left, and vice versa. If an object is moving to the left, right, if the direction of motion is to the left, then it will experience friction to the right. Okay, the friction always opposes the motion. And like this, even up a slope, if you have an object moving up the slope, okay, so it's accelerating up the slope, what direction will friction be? Friction, the kinetic friction will always be downwards. Okay, it will always be downwards, it always opposes the motion, and vice versa. If an object is moving down the slope, then what direction will the friction be? If the object is moving down the slope, then the friction will be up the slope. Okay, so in this circumstance, they've told us that the block A is moving upwards, therefore kinetic frictional force will be downwards. So we'll draw that over here. Basically, it will be down the slope, and that will be our Fk. Fk standing for kinetic frictional force. Kinetic frictional force. So this will give us our 4 marks for the 4-mark question of 2.2. The free body diagram is consisting of normal force, tension, kinetic friction, and gravitational force. Then looking at question 2.3. Question 2.3 says, calculate the magnitude of 2.3.1, the tension in the string. Okay, so now the next question they want us to do in 2.3.1 is, they want us to calculate the tension in the string. Remember we said that the string contains tension. Now they want to know what is the value of that. Right? We have to give them the numerical value of what is the amount of tension that is contained within the string. So we'll keep our free body diagram here. It's very helpful in terms of comparing where the forces are in relation to each other. And let's just make a note, we're busy with 2.3.1. How much marks is this question? It's a 4-mark question. Okay, so if they ask you a question like this, calculate the tension in the string, how do we go about answering this? I would advise that if you are following along on the video right now, to please keep a formula sheet in front of you. In the exam, the formula sheet is your best friend. Okay, it's absolutely your best friend. It's what you're going to need to guide you along as you go through the paper. And because you're doing Newton's laws, right? What section in the formula sheet is going to be relevant for us? It will be force. Okay, so Newton's laws, that on the formula sheet where you receive all of the formulas, the section that will be relevant for you and helpful to answer question 2's Newton's laws is the area on your formula sheet which says force. Okay, and if you look over there, you'll have all the formulas relating to force, and these are all the formulas relating to Newton's laws. So to answer in terms of tension, calculating the tension in the string. Which of these formulas will be most useful for us? The formula that's going to be for what I call your best friend is F net is equal to M times A. Okay? F net is equal to M times A. Okay. Let's just keep in mind, what are we calculating now? Tension. Okay, we're just putting T question mark. So we're looking now for the tension in the string. What is the amount of tension in the string? So in order to answer that, or any question similar to that, this is a very valuable formula. This is the formula you get used to answer that question. Okay, F net is equal to M times A. What does F net mean? Net means total. So F net stands for the net force, the total force. Okay, the total force that the block is experiencing, it is equal to MA. M stands for mass. Okay, M is the mass of the object, and A stands for acceleration of the object. Okay, so total force is equal to mass of the object multiplied by the acceleration of the object. These two aspects are very easy for us to fill in. They gave it to us. We know the mass of the object. Okay, we're looking at it from the perspective of block A, because we already have a free body diagram for block A. We have T over there. We know how T is located. So from block A's perspective, the mass of block A is 4 kg. So we know what M stands for. And the acceleration of block A, that they've also given to us. Okay, if you look at the information given to us in question 2, they say a constant force F acting parallel to the plane is applied to block B as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. Okay, so we know what A is. They told it to us. They said the blocks accelerate up the plane at 2 meters per second squared. So that's nice. We know what these values are. But now, what do we fill in by F net? When they say total force, what is the total force? Okay, so we need to actually look at it from a perspective that is relevant to us. What are we looking for? We're looking for tension. Okay, that's what we're looking for, tension. So when you talk about total, you can either only discuss total in the x direction, or you can discuss the total in the y direction. Okay, over here, let's consider everything on this plane. We'll consider this in our x direction. Okay, so this is our x direction, and everything in this direction over here, we will consider it our y direction. Okay, so that's what we mean when we say F net. You can only consider F net x. Okay, the total forces in the x direction, or you can consider it to be F net y, meaning all of the total forces in the y direction. Okay, is it okay? Is it acceptable for me to put that the F net, the total forces, is a normal plus tension plus Fg plus Fk? Is it allowed for me to do this? No, this is not allowed, right? This is not possible. Why? Why can't I do this? Why can't I say the total force is N plus T plus Fg plus Fk? Because I'm mixing up the horizontal and y directions. Okay, I'm mixing up the normal force is a y direction, tension is an x, it's in this plane, the x plane, and Fg is in also in the y direction, and Fk is in the horizontal plane. So you can't do this. We have to only consider all of the forces in our horizontal plane. Well, I know it's not technically actually horizontal. Let's call it the x-axis. Okay, this plane over here. So we add up all of the forces in this plane. Why are we adding up all of the forces in this plane? Because we're looking for T, right? And T lies in this plane over here. So because tension is what we're looking for, we have to add up all of the forces lying on this specific plane over here. This Fg, though, it's a bit of an inconvenience because this doesn't fall in either of the planes, right? This Fg goes directly downwards. It doesn't exactly fall in the horizontal in this x plane, nor does it fall exactly in the normal plane. But that's fine. What we can do with this Fg, which is the gravitational force downwards, is divided into two components. Okay, we're going to divide it into a parallel component, a component parallel to the plane, and we're going to also divide it into a component perpendicular to the plane, right? So let's just look at the actual block itself, right? The actual block goes like this, okay? So we have the actual block over here. What is it experiencing? It's experiencing a gravitational force of the Earth directly downwards, okay? So the actual force of the Earth is directly downwards. However, we can break it up into a component perpendicular to the plane. How does that look? Here. Right? So the original Fg gravitational force, well, we break it up into this component over here, which is what we call Fg perpendicular. Okay, we call it Fg perpendicular. This is the perpendicular component of the gravitational force. What is it perpendicular? It's perpendicular to the plane, right? This angle over here between this force FG perpendicular and the plane will be a 90-degree angle. And the other aspect that we also break it up into is a component which is parallel to the plane. Okay, so we're breaking up FG into two components: a component which is perpendicular to the plane, and another component which is parallel to the plane, which we write it like this: FG parallel. Okay, can you see it's parallel? They're basically going at same angles to each other. Now, another important thing for you to remember is this 35 degrees. What is this 35 degrees? This is the angle of the slope. It's the angle that the slope is making with the surface. This over here, mathematically speaking, can also be transferred to this angle over here, okay? So that angle over there and this angle between FG and FG perpendicular is the exact same value. Okay, so that 35 degrees is also the angle that is between these two lines over here. That is 35 degrees. This is important to remember in terms of working out what the value of FG parallel is. Okay, so to recap, we've broken FG, the gravitational force, into two components: a perpendicular component, perpendicular to the surface, and a parallel component, which is parallel to the surface. So therefore, just in terms of our free body diagram, let's just note that over there. So I'm going to erase the FG, and I'm going to put the components instead. And it's perfectly acceptable to give this as an answer for your free body diagram in the previous question as well. Okay, so the FG, you have one going downwards, which is what we call FG parallel. It's the parallel component of the gravitational force, and there's another force over here, which is FG perpendicular. Okay, FG perpendicular, which is the perpendicular component of the gravitational force. Now, this is easy to work with in terms of F net, because remember F net, we try to solve for what is tension. What is the tension in the string? And so we have to look at the total forces in this x direction. When I say x direction, I mean these forces over here at this particular in this particular slot. In physics, direction is also very important. Okay, we will choose that anything going upwards, we're going to make it a positive value, and anything going downwards, we're going to make it a negative value. It's very, very important when applying Newton's second law, F net is equal to ma. You must beforehand already identify what your directions are and what their signs are. Okay, so we're going to go with upwards, it's positive, downwards, negative. Okay, very important. You can't just make all of your values positive. So therefore, tension, we see what direction is tension, what direction is the block experiencing tension? Upwards. So therefore, it will be a positive value. Why? Because the direction of tension is upwards. Now, remember, if that means we're adding all of these things. Then Fk, however, is downwards. You see, it experiences a frictional force downwards. Therefore, remember we said anything downwards is negative. So it'll be negative Fk. Fg parallel is also downwards. Gravity always pulls things downwards. So gravitational force will always be in a downwards direction. Therefore, it's also negative Fg parallel. Okay, negative Fg parallel. Remember, we're just looking at the parallel component. So we're not looking at the gravitational force in its entirety. We're only looking at the parallel component of the gravitational force. So these are our total forces, specifically in this x direction. And there's the thing that we're trying to solve. Here's the unknown. You know, it's similar to mathematics, solve for x. In this case, we're not solving for x, we're solving for t. Is equal to ma. So let's put in now the values that we do know. T is the unknown, which is what we need to solve for. We do know Fk, right? We do know the kinetic frictional force of block A. It was given to us in the information when they told us about question A, question 2. Remember they said that? Oh yeah, there we go, right? They said that the kinetic frictional forces acting on block A and B are 5.88 newtons and 13.23 newtons respectively. So the frictional force of block A is 5.88. So let's fill in the values we know. T is, we don't know what that is. We're trying to solve for that. Fk, the kinetic frictional force, is 5.88 newtons. Okay, now Fg parallel. What is Fg parallel? What is the value of the parallel component of the gravitational force? To answer that, we need to use a bit of trigonometry. Okay, and we're using a little bit of trigonometry in terms of this triangle. Can you see we've created a triangle for ourselves on the board? If you just look over here. This is the triangle. There's an angle that we know that's 35 degrees. Here's one, the Fg perpendicular. This side over here is Fg parallel, and then we have Fg. You can see this, the angle between Fg perpendicular and Fg parallel, that itself is also a right angle triangle. Okay, these two, FG perpendicular and FG parallel makes a right angle with each other. Therefore, can you remember from mathematics? Anything that's opposite anything that is opposite the right angle triangle is hypotenuse. Right? Anything lying opposite the right angle triangle is hypotenuse. So therefore, FG, this line over here, which is FG gravitational force, is the hypotenuse. Let's put H. So you remember that is the H. Okay. And now, do you remember from mathematics? What do we call the thing that is opposite the angle? We call it opposite, right? That's exactly what we call it. Anything opposite the angle, any side that is opposite the angle, we call that side the opposite. So I will just write the O over there. Okay. And so the FG is the hypotenuse. And automatically, if FG is hypotenuse, if FG parallel is the opposite, then what is FG perpendicular? That is automatically the adjacent. Okay. In mathematics trigonometry, we call that side that is not the hypotenuse, that is not the opposite, we call it the adjacent to the angle. Okay. And now remember, what are we trying to figure out? We're trying to figure out what is the value of FG parallel. And so we need to use trigonometry to figure that out. Do we know the value of the original FG, the gravitational force? Yes, we do. We can figure it out. Okay, what is FG equal to? The formula, which you can also find on the formula sheet if you can't remember it by memory. Let's see, will you find the yes? Yeah. On the formula sheet, they actually have it as W. Remember, we said you can either call it FG gravitational force or you can call it weight. They refer to the same thing. Okay, the FG and W is referring to the exact same thing, gravitational force. So on the formula sheet, you actually have it as W is equal to, but it's however the same thing. What is the formula for this? It's equal to mg. Okay, so the gravitational force of any object is equal to mg, which is its mass times the gravitational acceleration. That is how you calculate the gravitational force for any object. Its mass times the gravitational acceleration. Okay, so we know what FG is, right? And so now we need to figure out the opposite. So we have to think of trigonometry. In trigonometry, what are the various ways you figure out opposite? Remember, in trigonometry, you have sine theta is equal to O over H. You have cos theta is equal to A over H. And then you have tan theta is equal to O over A. O over A is tan over. Yeah, that's how I remember it. I remember it like sin no, cos and tan over. That is just my way, but I'm sure you can use any way that how you personally prefer to remember it. So we're looking for FG parallel, which is the opposite in this triangle scenario. So we need a formula to use that has opposite in it. So our options is either sine theta, because that has opposite in it, not cos. We can eliminate cos, because cos is A over H. We're not looking for adjacent, we're not looking for hypotenuse, so we eliminate that. So either we're going to use sine theta, which is O over H, or we're going to use tan theta, which is O over A. So which one? We actually can't use tan, because in order to use tan, we try to figure out what is the opposite, what numerical value is opposite. We need to know adjacent. Do we know what the value of adjacent is? FG perpendicular? No, we don't know what the value of FG perpendicular is. Therefore, we can't use tan theta. We will scrap that. So the only option to figure out what the FG parallel is, which is the opposite in this circumstance, is sine theta. Sine theta is equal to O over H, because we have hypotenuse. We know we have a number for hypotenuse. What is the hypotenuse over here? It's the FG. Okay, FG is equal to mg. So we know the mass of the object is 4 kilograms, and g, which is gravitational acceleration, is a constant. It's always 9.8 meters per second squared. That is always a given that you don't ever have to figure out for yourself. So if we just reshuffle this, sine theta is equal to O over H. What is O equal to? If we just need to take the H over to the other side. How do we take it over to the other side? Basically, if you think back to mathematics, we get rid of the H by timing by itself. Because anytime you have a value in the numerator and the same value in the denominator, what's going to happen is going to cancel out. Okay, and the other thing mathematically, which is very important, is whatever you do to the one side of the equation, you must always do the same thing to the other side of the equation. Okay, so we try to get rid of the H because we just want to know what O is equal to. So we say multiplied by H because then it will cancel out. The H on top will cancel out with the H at the bottom. Because we multiplied this side by H, we have to multiply that side by H. And so we end up having O is equal to H sine theta. Okay, which is what we want to know. What is O equal to? Opposite is equal to H sine theta, which is hypotenuse multiplied by sine theta. What is theta? Theta means the angle. Okay, what is the angle we're dealing with over here? That's 35 degrees. Okay, it's the slope it's the angle of the slope, which is 35 degrees. I'm just turning it around. It's still referring to the same thing. O is equal to H sine theta. In this circumstance, our O is FG parallel. Okay, why is that the O? Why is that the opposite? Because it is opposite the 35 degrees. Okay, it's opposite there. And this you have to, you see, it's very important when you're doing physics, your mathematics knowledge also has to be strong, because physics involves you understanding your mathematical trigonometry information very well as well. So make sure, you know, to have a solid mathematical background at the same time. So if I just change these, the O in this circumstance is FG parallel. What is the H in this circumstance? The hypotenuse is the FG. It is the original FG gravitational force, which is mg, and then it's sine theta. Okay, so FG parallel is FG sine theta. Let's just expand on what FG is. What is the formula for FG? The formula for FG is mg. Okay, that gravitational acceleration is equal to mass. The gravitational force is equal to mass times gravitational acceleration. Okay, so I know some of the students, alhamdulillah, some students are fast. Some students know this already. However, there might be some students in the audience that this is a bit shaky. Okay, so please bear with me. Those students who already know this knowledge, maybe it's already like, you know, like the back of your hand. Just bear with me for going slowly through this, because there might be some other students out there for who this might have been a bit shaky knowledge. So just a revision of this. So the parallel gravitational force is equal to mg sine theta. I would honestly suggest for examination purposes memorize this. Okay, why I would suggest memorize this is because are you going to get marks on this all of this in the exams? No, you're not going to get marks for going from that trigonometry perspective to this. Okay, you don't get no marks for this. So the only thing that you're actually going to get marks on is this part over here. Therefore, I would say make sure to study well before exams so you understand how we got to this. Okay, so you're not blindly memorizing. You do understand the process to how we got here. But now that you know, for example, just memorize this. The FG parallel is equal to mg sine theta. The parallel component of the gravitational force is equal to the mass times gravitational acceleration times sine theta. So that is what FG parallel is. It's mg sine theta is equal to ma. Okay. So now we can put in values over there. We know the m, we know the g, we know the sine theta. Okay, remember that is the mass. We're dealing with block A. It's 4 kilograms. G stands for gravitational acceleration. That is a constant given to you in the exam on your formula sheet. It's always 9.8 meters per second squared. And sine theta, the theta over here in this scenario is referring to the angle of the slope, which is 35 degrees. Okay. And then it is equal to mass times acceleration. What is the mass? Again, we know the mass, it's 4 kilograms. What is the acceleration? They told us in the information that the block is going up the slope at 2 meters per second squared. So the A acceleration is 2. So this is where we've gotten thus far. So now remember, what do we need to solve for? Let's just recap the question that they asked. The question that they asked in 2.3.1 was calculate the magnitude of the tension in the string. So we have to calculate T. So can you see this looks very similar to mathematics now? What we simply need to do is solve for T. So can you see there's an equal to sign over here, right? So if you just read this out, it says T minus 5.88 minus 4 times 9.8 sine 35 is equal to 4 times 2. Okay, so we need to get all of these other numbers over to the other side of the equal to sign. Okay, so we need, the only thing that must be on this side of the equal to sign must be T. Okay, we want to know what is T equal to. Okay, so all these other numbers, we have to take it over to the other side of the right hand side. So of the equal to sign. So the 4 times 2 will stay where it is. Okay, and that is perfectly fine. It's exactly where we want it to be. So what happens when we take negative 5.88 over to the other side? It becomes positive. Okay, anytime we take values over to the other side, they'll become positive. So negative 5.88 will become positive 5.88. We're going to take this whole compound over here over also the 4 times 9.8 times sine 35. We're going to take this over to the other side of the equal to sign. Again, same thing happens. This negative in front, when we take it over, it will become positive. Okay, so that will become positive 4 times 9.8 times sine 35. Okay, so we've taken all these values over to the other side. Therefore, their signs changed. All the negatives became positive. So now we have T is equal to 4 times 2 plus 5.88 plus 4 times 9.88 times sine 35. If you put this in your calculator and make very sure to double check your answers carefully so you don't have any mistakes, this should give us a value of 36.36 newtons. Okay, and that is our final answer. The tension in the string is 36.36 newtons. And that's what will be required to answer the question. Let's just check this question that we did. It was a 4-mark question. Okay, so what will we get the 4 marks for? You'll firstly get a mark for putting this formula down. Okay, putting this formula down. You can either they actually allow you to either put this formula down, or you could put this formula down. Okay, but as long as you put some form of formula down, that's very important. One of these, and thereafter you'll get a mark for substituting it with numbers. Okay, so substituting the values inside of all the mg, the fk, and such. That's the other perspective that you get a mark for. And you also get a mark for putting in numbers by MA. The 4 times 2, you'll get a mark for that. And then lastly, you'll get a mark for the final answer. Okay. This memo that I'm looking from, you can find it on the government website. Okay. If you just put into Google, or I also requested VOC to have it on their website. So inshallah, if it's uploaded there, do check on the website. If not, all these NCS November 2023 examination papers is on Google. You can just Google physics MATRIC November 2023 and this will show up. So please do look at the memo as well to see how they give mark allocations for these sums. Then going on to question 2.3.2, which is a 3-mark question. Question 2.3.2 says, calculate the magnitude of the force F. Okay, so now they want us to calculate the magnitude of the force F. Where is force F? Force F is over here. Right? Can you see on the diagram? It's being pulled up. Let's just read the information again. They say a constant force F acting parallel to the plane is applied to block B, as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second. So there's a certain force. Maybe the force is being pulled by someone or something, but a force is being applied, and they very specifically say to block B. Okay, so this force is not being applied to block A, it's being applied to block B, and is causing the blocks to accelerate up the slope. So now what they want us to do is calculate the value of F. What is F? What is the amount of F? So again, to answer this, we'll once again use the very important formula of F net is equal to M times A. Let's just check this is question 2.3.2. Okay, and what are we looking for? F. The force F that is pulling block B up the slope. So in order to answer this, we once again going to use F net is equal to M times A. So you see this formula is very important for your question 2s. In all the exams, question 2 is always your Newton's laws questions. And in order to answer it, this is the most important formula that you have. F net is equal to M times A. The net force, meaning the total force on the object, is equal to its mass times acceleration. This is really your best friend when it comes to Newton's laws. So now, however, previously, when we answered this question, we looked at the free body diagram of block A. But in this circumstance, can we still look at the free body diagram of block A? No, we can't, because there is no F over here, right? There is no force F. There's only tension, kinetic frictional force, Fg parallel, Fg perpendicular, and normal force. And so where is F being applied to? It's being applied to block B. So therefore, we have to look at it from block B's perspective. So we're going to erase the free body diagram of block A because F does not exist over here. And we're going to draw a free body diagram from block B, because block B is the one that's experiencing a force F being exerted on it. And because F is in this direction, right? It's in this parallel direction to the slope. We're only going to consider all of the total forces in the parallel direction, okay? Because F net, in this circumstance, we're only considering the total forces in this parallel direction, because that's where F is. So what other force acts in the parallel direction on block B? Maybe we're looking at it now from block B's perspective. The other force is also the tension, right? Because remember, block B is also attached to a string. Anytime something is attached to a string, it's going to experience tension. What direction is block B going to experience tension? It's going to experience tension downwards. Okay? Why downwards? Because the string is behind it. Since the string is behind it, think about it. If someone had to put a string at the back of you, then you're going to be pulled in the backwards direction because the string is behind you. So it will experience a tension downwards. Similar to block A, block B will also experience friction, okay? Because they've told us that it has a frictional force, therefore it's experiencing friction. Because block A is moving upwards, the friction will be downwards. Because remember, friction is always in the opposite direction of motion. So because block B is moving upwards, it will experience friction, kinetic friction downwards. What other force is there? The other force acting on it will also be the parallel component of the gravitational force. Remember, we're only considering all of the forces specifically in this parallel direction to the slope. So lastly, the other force will be the, let's put it over here. It will be, okay, FG parallel. And remember, all blocks will always experience an FG parallel force downwards, which is the parallel component of the gravitational force, which causes the block to experience a gravitational force downwards. Any block that you're dealing with, it must experience gravity as long as you're on Earth, right? Maybe if you're in space and you're floating through space, there'll be no gravity. But as long as any object is on Earth, it's going to experience a parallel component of a gravitational force. So now we know these are the F net, specifically in this parallel direction. So let's put it over here under what F net is, the total force. Very important again, we're taking up any object that is going, so any force going upwards, if we're going to consider it positive, any force going downwards, we're going to consider it to be negative. Very important to identify this before we put in our symbols. So if it's an upwards force, so it's going to be positive F. Everything else is downwards. FG parallel downwards. Tension, the block is experiencing a tension downwards. FK is experiencing a kinetic frictional force downwards. So all those other values will be negative. It will be negative FG parallel, negative tension, and negative kinetic frictional force is equal to MA. Here we just continue to see, all we simply did was we substituted what is F net. What are the total forces? It's F minus FG parallel minus tension minus kinetic frictional force. And this time we leave the same, is equal to MA, which we know what M is. The mass of block B is 9 kilograms. We know the acceleration the block is experiencing, it is 2 meters per second squared. Yeah. So you see, sign is very important. A lot of students make a mistake where they don't put the correct sign, and therefore they get the final answer wrong. And now the nice thing is that we know already what FG parallel is. Remember we said from trigonometry, just make sure to memorize that FG parallel is basically, it's always mg sine theta. So we're not going to go through that whole scenario of how we got to it. We use trigonometry, but FG parallel is mg sine theta. Minus t minus fk is equal to ma. Okay, what are we looking for? We're looking for F, okay? F is the force being applied on block B. So this is the unknown that we need to solve for. And so since we need to solve for this, we don't know what it is. This is what we need to solve. Therefore, we should have the values of all of the other symbols over here. We should have a numerical value for them. Minus mg sine theta. M, the mass of block B, is 9 kilograms. G stands for gravitational acceleration. There is a constant, meaning it's always 9.8, okay? It's always 9.8 meters per second. This value is given to you in a formula sheet in the exam. So you don't have to memorize, it will be given to you as part of your formula sheet. Sine theta, theta, that over there refers to the angle of the slope, which we see the angle of the slope is 35 degrees. Minus tension, this tension, we know the answer to it. We calculated it in the previous question. Remember, we already calculated what this is in the previous question. So you just go back to your previous answer, and the tension we found was 36.36 newtons. Minus Fk, Fk referring to the kinetic frictional force of block B, which they've given us in the question information. They said block B has a kinetic frictional force of 13.23 newtons. Okay, so where did we get 13.23 newtons? This was given to us in the information. They said to us that the kinetic frictional force acting on block B is 13.23. Is equal to MA. M is mass of block B, which is 9 kilograms, and A stands for acceleration that block B is experiencing. They said to us in the information in question 2, there is 2 meters per second squared. So that 2 was also given to us in the examination question, that the blocks are accelerating up the slope at 2 meters per second squared. So now once again we're solving for F. Okay, so we have only one unknown F, and we try to figure out what is F equal to. So what we need to get to is F is equal to. Okay, but to know what is F equal to. So we need to, can you see there's an equal to sign over here? So all these numbers, we must take it over to the other side of the equal to sign. Okay, we want F all by itself. We want to isolate F, and the only thing we want to have on the left-hand side of the equal to sign is just F. all of these other numbers need to be transferred to that side. Okay, transferred to that side. Now, important to remember is whenever you transfer numbers to the other side of the equal to sign, the sign changes. Okay, meaning that negatives become positive. When you take a negative value over to the other side of the equal to sign, it will become positive. If you take a positive value to the other side of the equal to sign, it will become negative. Okay, so the signs always swap around. So over here, already on the right-hand side of the equal to sign, we already have 9 times 2. So that will stay there. Okay, we keep that there. That's exactly where we want it to be. Now we need to take this whole value over here over. Okay, and can you see there's a negative? So when you take it over to the other side, the negative will become positive. So that whole value over there will become positive. 9 times 9.8 times sine 35. Okay, so that whole thing, we took it over to the other side of the equal to sign. When that happened, the negative became positive. Likewise with this, when you take negative 36.36 over to the other side of the equal to sign, the sign will change. So the negative will become positive, positive 36.36. And likewise with this, negative 13.23. When you take it over to the other side of the equal to sign, it will become positive 36.36. Okay. So what we've done here is we've simply taken all these values to the other side of the equal to sign. Why did we do that? Because we tried to solve for f. We want to know what is f equal to. So the only thing we want on the left-hand side of the equal to sign must just be f. Okay, f is equal to 9 times 2 plus 9 times 9.8 sine 35 plus 36.36 plus 13 plus this value will be at 13.23. Okay. And now when you put all of these values in the calculator, the answer you should get for this will be, let's see what they say, it will be 118.18 newtons. Okay, so that will be the value for all of, when you add up all of these values over here. That F is equal to 118.18 newtons. So that is the answer to question 2.23, which was 2.232, which said calculate the magnitude of force F. So now we know this force over here that is pulling block B upwards. The value of this force is 118.18 newtons. And how did we solve it? To recap, we solved it using this very important formula. F net is equal to MA. So you see, we use this to answer question 2.3.1 and also 2.3.2. So a very, very important formula that you use for question 2. F net is equal to MA. The net force, meaning the total force, is equal to the mass of the object multiplied by the acceleration of the object. Okay. Am I good on time? Okay, hopefully I'm good on time. 2.4.2, which is just a theory question, so it won't take long. 2.4 says the angle that the plane makes with the horizontal is now decreased. And then 2.4.1 says, how will this change the kinetic frictional force acting on block A? Choose from increase, decreases, or remains the same. And then 2.4.2 says, explain the answer to question 2.4.1. Okay, so let's just erase this. Let's just recap again. What is it asking in question 2.4? They're saying that the angle that the plane makes with the horizontal is now decreased. Where is the angle that the plane makes with the horizontal? They're talking about this over here. Remember, what is the original angle? The original angle was 35 degrees. Okay, so the angle between this plane and this horizontal ground over here is 35. So now they're saying, just imagine, okay, hypothetically speaking, just imagine that this angle is decreased. So it's no more 35, it's less than 35, right? It's decreased. So maybe it's 30 or maybe it's 20 degrees. So it's a smaller angle. Okay, so they're saying that this angle has become smaller. And now they say, how will this change the kinetic frictional force acting on block A? Will the kinetic frictional force, will it increase, will it decrease, or remain the same? Okay, so they're asking, how will the change in angle affect the kinetic frictional force? And what is kinetic frictional force? Remember, the Fk is the friction that the block experiences. So they want to know if we decrease the angle of the slope, will the kinetic frictional force, will that increase, decrease, or will it stay exactly the same value? Okay, and they want to also, in 2.4.2, we need to explain the answer in terms of how we got it. So let me just tell you what the answer will be. The answer for 2.4.1 will be increases. Okay, the kinetic frictional force will increase. But now, of course, we can't just give an answer. We need to explain why, right? We have to show the proof. Why is the kinetic frictional force? Why will it increase if the angle decreases? If the angle of the slope gets smaller? And the reason for that, which we have to give in 2.4.2, in terms of why the kinetic frictional force will increase, is that you have to look at the formula for kinetic frictional force. And this you'll find on your formula sheet. Okay, if you can just pull out your formula sheet. Let's see where, oh, there it is. Okay, you will see it in your formula sheet, which is this formula. You have to analyze the formula if K is equal to coefficient of kinetic friction multiplied by normal force. Okay, so this over here, this is not a formula you have to memorize. It's given to you in the exams under the section force. Okay, remember there's a section on the formula sheet entitled force. If you go there, you will find this. And this formula states Fk is equal to, so kinetic frictional force is equal to coefficient of kinetic friction multiplied by normal force. However, how does it show the relationship between kinetic frictional force and angle, right? Because that's what we're trying to actually analyze. We're trying to analyze what is the relationship between kinetic frictional force and the theta. Okay, theta meaning the angle. So how we join the two and how we establish a relationship between kinetic frictional force and the angle is just to expand on the normal force. Okay, what is the normal force? Remember, if you look at block A, we didn't draw the forces in the y direction, but let's just draw it. The one force that the block A experiences in the y direction is in, and this is in, right? N is the force of the surface. It's the perpendicular force of the surface on the block. So it's like this, okay? However, what is the other force experienced in the y direction? It's this force over here, which is the FG perpendicular, okay? This is the other force in the y direction, is the downwards FG perpendicular, the perpendicular component of the gravitational force. And what you need to remember from physics, which your teacher would have taught you, is that this normal force, it always balances whatever the downward force is, okay? The normal force is always balanced and it's always equal to, okay, what is the normal force equal to? It's always equal to the downward force. And what is the downward force over here? It's FG perpendicular. Okay, and when you do trigonometry, I'm not going to do the whole trigonometry thing. We see over here FG perpendicular from a trigonometry perspective is the adjacent. Okay, in this triangle, FG perpendicular is the adjacent. So if you work on solving it, right, and we won't go through that just for lack of time, but if you go solve it, what is equal to, you will find that is equal to mg cos theta. Okay, mg cos theta. Because remember cos theta, what is cos theta equal to? Cos theta is equal to A over H. Okay? Cos theta is equal to adjacent over hypotenuse. So if you just rearrange the formula, therefore adjacent will be equal to cos theta multiplied by hypotenuse. Okay, and in this circumstance, our adjacent is FG perpendicular. Right? The adjacent is FG perpendicular because it's adjacent to this angle over here. Cos theta, our hypotenuse is what? Our hypotenuse is FG. Okay, it's the FG because it is opposite the right angle triangle that is made here between FG perpendicular and FG parallel. Okay, and then what is FG? FG is equal to mg, right? FG is equal to mass times gravitational acceleration. So therefore, FG perpendicular is equal to mass times gravitational acceleration cos theta. Okay, so that's basically how you get that FG perpendicular value. FG perpendicular is equal to mg cos theta. But I would suggest for examination purposes, make sure to memorize that so you don't have to work out all of the trigonometry because you don't get any marks for this, okay? You don't get marks for figuring this out. They just want to see the final result. So FG perpendicular is mg cos theta. So going back to normal force, what is normal force equal to? It's always equal to the opposing downward force because they balance each other out. Is this block jumping up and down? No, it's not, right? The block is only going up the slope, but it's not jumping up and down in this y direction. So the fact that it's not jumping up and down means it's completely still from the y perspective. Okay, therefore, the normal force will balance the downward FG perpendicular force. So what this means is that normal force is equal to FG perpendicular. Okay, they are equal to each other. Like the normal force is equal to whatever the downward force is. So N is equal to FG perpendicular. And what is FG perpendicular equal to? It's equal to mg cos theta. Okay, FG perpendicular is equal to mg cos theta. So now let's substitute this in this formula over here. Okay, the formula of what Fk is equal to. Fk is equal to the kinetic frictional force is equal to the coefficient of kinetic friction multiplied by the normal force. And what did you say? What is the normal force? It's equal to the downwards Fg perpendicular, which is mg cos theta. So normal force is equal to mg cos theta. So let's substitute this. We substitute it into where the n is. Okay, so it's equal to mg cos theta. All I did was substitute that mg cos theta into the normal force, because that is what the normal force is equal to. And now we can finally see the relationship between kinetic frictional force and the angle. Okay, because that is what the question is asking us for. The question is asking the angle that the plane makes with the horizontal is now decreased. How will this change the kinetic frictional force acting on block A? Will it increase, decrease, or will it remain the same? Okay, so now we see the relationship. What happens? Remember they said this will get smaller. Okay, they said this angle is going to decrease. It's no more 35, it's less than 35. So what you need to remember from the mathematical perspective is anytime this value gets smaller, okay, anytime this value gets smaller, your cos value actually gets larger. Okay, so when you decrease the angle, it actually makes this answer as a whole, it makes it larger. So we see we have the indirectly proportional relationship. Okay, indirectly proportional means that as the theta gets smaller, your Fk, your kinetic frictional force, will get larger. Okay, you can even put this in. You can even put this yourself in a calculator to see that. Put cos 35 and then put cos 20. You'll find that the smaller the angle, the larger your final answer will be. So therefore, it's an indirectly proportional relationship. Let's just see how they want us to word it. How they wanted to word it is you should say that frictional force is directly proportional to normal force. Okay, right? Which means that this frictional force over here, because mg cos theta is equal to the normal force, when this gets larger, then this frictional force will also get larger. Okay. So as this gets larger, then your final answer of what the friction will be will also increase. So going back to question number 2.4.1, our answer will be that it will increase. When you decrease the angle, the frictional force will increase. I will conclude over here. This is a 60-mark answer for question 2. And this is Newton's laws. I hope this gives some clarification, inshallah. And I make dua that Allah allows you to do very well in your exams. And may Allah open your heart and open your mind towards understanding the questions and understanding how to solve the answers. Ameen. All the best, inshallah, with your further studies. Assalamu alaikum wa rahmatullahi wa barakatuh.
MashaAllah, we say Alaikum salam wa rahmatullahi wa barakatuh to the Honorable Mu'allima Fatima Karbary, who so beautifully rendered the facilitation for today's physics preparation, inshallah, for physics paper 1. We'd like to say shukran, jazakallah khair to Mu'allima Fatima Karbary once again for facilitating today's session. May Allah Almighty reward you. And I know that the matriculants will benefit greatly from your discourses and from your advice as to how they should approach preparation for their physics paper, inshallah ta'ala. With this said, beloved viewers on the Voice of the Cape's YouTube page and Facebook page, as a reminder once again that this is in the continuation of the series of the matric revision sessions that we at the Voice of the Cape are hosting. And of course, as a reminder, the Voice of the Cape's online matric revision program is, of course, this year in collaboration and is proudly being sponsored by the Two Oceans Graduate Institute. And it is a accredited online platform where you can become a primary or a high school teacher. And as a means of further information for those who would like to find out more about this, you may visit their website www.togl.ac.za, or you may call them on 021 829 7015. This brings us to the end of this particular session for physics, as hosted by the respected Mu'allima Fatima Karbary. And as a reminder, once again, please like and share this particular link on Facebook and YouTube with all